Hi guys, today I'm going to just get into some vocabulary with you. It's kind of a good time to bring up some old vocabulary because we will be moving back into confidence intervals. So I just want to remember, because what today is kind of like is, when you guys learned about confidence intervals, and whenever you see a confidence interval, you need to make sure that you're interpreting the confidence interval. And you guys have done this 100 times. Basically, you say, we are, 95% confident the true population proportion or true population mean is between these two numbers. And for an example, this is a problem I gave you a printout of a long time ago with the ghost problem, and we did a confidence interval, and then we have to interpret the confidence interval, and that's where we said I'm 90% confident the true population proportion of adults who believe in ghosts is between these two numbers, and you've done that 100 times. Now the question is, what does the level mean? So if I said to you, I want you to interpret the confidence level, meaning 90%. Okay, now that's a totally different question. And you don't have to do that every time you complete a confidence interval, but it's something that definitely comes up. So this is a review, hopefully it is. And I want you to write this down if you don't have it, but notice, interpreting the confidence level, what it means is if we were to construct many confidence intervals from the same population of the same sample size, blank percent, 90%, 95%, whatever you're using, of them will capture the true population parameter. So you should have this in your notes. I'm just reviewing this because, this you do 100 times. This doesn't happen as often. So I just want to review it because it could come back. It will come back. I've seen it on AP exams. So for this problem with the ghosts, if I said, okay, let's interpret the confidence level, we would say if we were to construct many confidence intervals taken from the same population of the same sample size, 90% will capture the true population proportion, and then tie it to the story, of adults who believe in ghosts. Okay, so that's the difference between, just a review of interpreting a confidence interval, which you do 100 times, versus interpreting the level. And that's an example of how you apply it to a story, the true population proportion of adults who believe in ghosts. So now we move into significance tests. And there's something you do, every single time you complete a test, is you make a conclusion. And your conclusion is, your PLAR or your PGAFR. And then remember, this is PLAR-TIS and PGAFR-TINS. Okay, but are you rejecting the null hypothesis, or are you failing to reject the null hypothesis? That you do every single time you do a significance test. But what ends up happening is they also could ask you, well, what is the meaning of the p-value? So not just make a conclusion from it, but what in the world is a p-value? And it's funny because I remember years ago, I had students come back from the AP exam and they were like, what's a p-value? What is it? And I kind of put my head down. I was like, oh my gosh, how do they not know this? But at bare minimum, I need you to know that a p-value is a probability. And if we get really good, we're going to know the definition. So here is how you would interpret a p-value. Not make a conclusion, but understand what a p-value is. So a p-value is the probability of getting a sample as extreme or more extreme with the assumption that HO is true. Okay? So bare minimum, please know it's a probability. P-value P, it's a probability of getting that sample at that point or more extreme with the assumption that HO is true. So, let me turn this over. And if you need to pause this for definitions and whatnot, I already have them written out to save me time. So, let's take a look at this. So this was a problem we did, chapter 8 maybe. And, we had our null hypothesis, which said that 19% of the population of the adult residents are Hispanic. And the assumption was that, well, that's going to be the same, for the number of jurors who are representing a jury. So we just, that's the assumption. We took a sample and it actually was less than. So when you guys find your p-value, you guys are finding this area. You've done that a million times. Z-scores, normal, ZDF, but now you have your test menus that can help you with this. So you're finding the area. Now notice what's happening. When we find our p-value, so this is the assumption we're making, is that 19%, if the population has 19% of Hispanic adults, then your jury should also represent the population. But they took a sample and it was 11%. It wasn't quite 19%. So we found the p-value. And because p was less than alpha, we rejected HO. And we said there's sufficient evidence to show that Hispanics are actually represented less on the juries. So here's how you would interpret the p-value. Not make a conclusion, but interpret the p-value. We would say 0.0439 is the probability of getting a sample as extreme or more extreme than 0.11, assuming the population proportion of Hispanic jurors was 0.19. So when you find this area, you're finding a p-value, and you're finding the probability of getting this sample or more extreme, which is why we either shade like below or less than, or further away, is kind of what they're saying, then the 0.11, with the assumption that 0.19 is a true statement, is the true proportion of jurors who are Hispanic. So when you reject the null hypothesis, this is a rare sample to get, and it starts to make you wonder, because we know they're not going to all be exactly at 0.19, but because this is such a rare sample, now we have to question whether or not the true proportion of Hispanics represented on this jury is truly 19% or if it's less than. And so that's what a p-value is. It's a probability, and that's the easy part to remember, of getting that sample or more extreme with the assumption that 0.19 is the true middle. Okay, so that's how you would interpret a p-value with the context to the problem, actually tying it in, because whenever they ask you to interpret a p-value, make sure you go back to the story. If you don't relate it to the story, you'll get points off. And then the last thing I want to talk about is, again, statistically significant. So Our results are found to be statistically significant if the p-value is less than alpha. And what that means is that when you reject HO. So what that means is it's not a sample that just happens by chance, it's a rare sample that's just occurred. So in that last problem with the jurors, we got a p-value of 0.04. We rejected the null hypothesis. It was less than our alpha of 0.05. So we said that our results are statistically significant because we rejected HO. So the sample does not happen just by chance. It's a rare sample. And that's what statistically significant means. So make sure you have these definitions. They come up, not as much as the other ones because you do those just by finishing a problem, but make sure that you know what a p-value is, what a confidence level is, and if you see the word statistically significant, remember you are rejecting HO. Okay, have a good day.